So in the last class, we have done with the topic of DB scan, density-based clustering algorithm. So here, so with the help of DB scan, we can able to identify the arbitrary shape cluster. So this is the last topic in clustering algorithm. And after that, we have only one topic left in fourth unit, that is outlier mining. So before going to that, let me briefly remind the previous topic. So here for DB scan, it can able to mine the clusters of arbitrary. It can able to identify the clusters of arbitrary shapes. So for that, there are some terminologies we need to know about that before going for the DB scan. That is epsilon neighborhood, and next min points are there. So for a particular point, if you consider an epsilon and the neighborhood exists with radius epsilon is called as epsilon neighborhood, and the minimum number of points within the epsilon neighborhood of an object is called as a min point. And directly density reachable in the sense, if at all another point is there, if it is within the epsilon neighborhood of that point, then it is called as directly density reachability. If at all this Q is outside the epsilon neighborhood of an point, then it is called indirectly density reachable if and only if whenever we are having certain set of points in between P and Q, where each point is a density reachability to with respect to the other point. If that is the case, you can call it as you can call these 2 points as indirectly density reachable. And when they are density connected, so an object O is P is density connected to object Q with respect to epsilon and min point. If there is an object belongs to D such that both P and Q are density reachable. So our final goal is to identify all the density connected points and to form the cluster with them. And we have also seen an example in the last class. And this is a manual process actually. So while going for an algorithm, there we need to identify the visited and unvisited points. So for constructing the systematical density-based cluster, first we need to randomly select one point, and we need to check whether it is an visible or visited and unvisited point. If at all that point is unvisited, let's mark it as a visited. Let's mark it as a visited. And from this point, you need to start the entire thing. That means you need to find out the epsilon neighborhood of this point, and after that, you need to check how many min points are there, and you need to check the density connected points to it. Like that, you need to start that. So initially, before that, initially you need to randomly identify one point, and initially you need to mark it as visible. Why? Because you are considering that presently. So all the things can be explained with an algorithm here. So here for the DB scan, you need to have some data set of n objects and the epsilon value. That means the radius of the neighborhood you need to have initially, and the midpoints also you need to have. That means number of neighbors for that object. And as an output you can have a density-based cluster. So initially you need to mark all objects as unvisited. So initially you need to mark all objects as unvisited. And after that, randomly you need to select some object P. You need to select one object. Some unvisited object you need to select and mark it as visited. You need to mark it as visited. So if the epsilon neighborhood of P has at least min point objects, so you need to first draw the epsilon neighborhood of P, and if that epsilon neighborhood has m number of minimum point objects are there, that means let's say this min points is equal to, for example, 3. So if the epsilon neighborhood of P has some three objects are there within this neighborhood, then you can add P to the cluster C. So create a cluster. So this is the way you can create the cluster. So you can create the cluster. So with that cluster, to the set of elements of that cluster, you can add P here. Now P is a part of that new cluster. Now you need to add all the remaining elements of that cluster gradually. So let N be the set of objects in the epsilon neighborhood of P. So how many objects you are having here? All these objects are belonging to the set n. So now we are having P here, Q here, R is also there in the set n. So now we need to create the set n. And next, for each point P dash in n, that means we need to identify each and every point in n. So P is also here. So let's say this is P dash. Let's say this is P dash. So for each point in n, if P dash is unvisited, since here my P dash is unvisited, so this P dash is unvisited, then mark P dash as visited. Because now we are considering this P dash, we need to mark it as visited. We need to mark it as visited because now we are, in previous case we have considered P and we have marked it as visited. And we have did some process and we add that P to the cluster. And now in the epsilon, within the epsilon neighborhood of P, we are going to consider some other point P dash. If it is unvisited, then you can select that point and mark it as visited. Visited, why we are marking it as visited means once it is marked it as visited, no need to consider it again. So here, if the epsilon neighborhood of P dash has, so that means what? Now we need to consider the epsilon neighborhood of P dash. So here this circle, this red circle is the epsilon neighborhood of P. Now we need to consider the epsilon neighborhood of P dash. For example, so this is the, let's say this is the epsilon neighborhood of this P dash. Now what to do? So if the epsilon neighborhood of P dash has at least min points, what it means? So if at all the epsilon neighborhood of P dash is also having at least min points, that means if at all P dash is also a core object, then add these points to n. Suppose there are some points points here in the epsilon neighborhood of P dash. So since these are equal to or greater than or equal to 3, you can fix that P dash is a core object. Now you can add all these points to n because you have the set n here, right? You have already some points here P dash and r. So along with these points, you can also add the remaining neighbors of the P dash. Let's say here some x is there, this point is A, and this point is B. So now you can add all these points to this set n. That means you can add A here, some B here, x here, like this. So now we are updating the set n. So if P dash is not at a member of any cluster, then add P dash to C. So after doing this, after updating the list n, now we are finalizing the P dash. First we need to check if it is a member of any other cluster. Since there is no cluster till now, this is the first cluster. So you can directly add P dash to this P. That means what here? Now we are forming a cluster with, initially we are forming a cluster with 2 objects. So in this way, this process repeats until you can have the all closest items. That means all density connected items together as a single cluster. So once you have done with this cluster, you can randomly select another unvisited point and you can again form the cluster around it based on the density of the neighbors. So in this way, you can proceed with the DB scan algorithm. And now coming to the last topic of the 4th unit, that is outlier. So first of all, what is meant an outlier? What are the outliers, first of all? Any idea? Outlier or noise? Any idea about that outlier? Did you heard the word outlier ever before? Any of you heard the word outlier? విన్నారా ఎవరైనా అవుట్లయర్స్ అంటే? I want the response.
Yes, ma'am.
What is an outlier? Just మీకు ఏం తెలుసో అది చెప్పండి.
Which does not contain the property of a cluster.
Come again.
The errors in a cluster. The errors in a cluster.
Errors in a cluster.
which do not have the properties the cluster has.
Yes, that means something, something the odd thing, odd element. So the essence of outlier, you have what you have tell is right. So outlier can be defined as a data object that are grossly different from or inconsistent with the remaining data. That means, for example, we generally use it to say like that, odd man out. అప్పుడప్పుడు మనం మాట్లాడుతూ ఉంటాం ఆడ్ మెన్ అవుట్ అలాంటి వర్డ్స్. వాట్ ఈస్ దట్ ఆడ్ మెన్? ఆ వర్డ్ ఎక్కడ యూజ్ చేస్తాం మనం జనరల్ గా? సపోజ్ యూఆర్ హ్యావింగ్ సమ్ in your class, suppose all of you are of height 5'2" or 5'3", like that. So this is the bar chart representing the height of each student. So this is all approximately of height 5.6 maximum. Suppose if at all a student is there in your class who is having height some 6'2", for example, I can say that he is the odd man in the class. That means the one which exhibits the different behavior with the remaining. Actually, Pinky, as you said, what you said actually, the outlier is the one which exhibits the different behavior than the cluster. But here it is not different from the cluster. We can't express like that. What you can say is an outlier exhibits the different behavior than the remaining data elements, not with the particular cluster. Actually, the in-depth meaning is with respect to the cluster only we can compare. But if you define the outlier, you can't use the word cluster. By eliminating the clusters, outliers only, you need to form the cluster. So you don't use the concept of cluster there. In general, you can talk like that. So in general, what we can talk is the outlier is the one which possess some different behavior with respect to the other data elements. So in this particular example, the outlier is the person who is very taller. That means whose characteristic is too different with the remaining persons. And also, if at all you are having a group of friends, and in your class you are having some set of people are there, and especially one person is there, one of your friend exhibits a different behavior. That means he is some moodist, he is not active, he is very calm, he is not he is possessive, like that. Compared to the all others, if at all he exhibits some different behavior, he or she exhibits some different behavior, then he is an outlier. Similarly, like that, outlier is nothing but the data element which possesses the different behavior with the remaining data, with the remaining all the elements. So here, if you observe, this is the distribution of the data points. This is the distribution of the data points. So if you observe here, these two data points fall far away from the remaining set of data points. So in this example, these two data points can be treated as an outlier. So why the outliers may exist in the data set? What are the reasons for these kinds of outliers in the data set? So that may be because of the measurement problem while measuring the values and recording the results. You maybe did some mistake because of the measuring instrument, or because of the execution errors, you may get the outliers, or inherently the data variability may also be the reason for the outlier. Data variability in the sense, like this example. That means there is no mistake. Actually, the person height is like that. The data is like that. Sometimes the data itself, that means inherently in the data, the outliers may exist. Or sometimes it may be because of some errors, some wrong entry. That means if the person's height is 5'4" only, but by mistake I entered it as 6'4", that is a typing mistake. So because of such kind of mistakes also outliers exist. Those are called as actually noises. Or otherwise, inherently the data may consisting of some outliers. Similarly, if you consider the salary of, or if you consider the age of all, what we can say, if suppose some child movie is there, some movie is there that belongs to children. Narnia is there, right? Children movie, Narnia. So if you have a data which includes the age group of all the audience for that children movie, if you consider the if you consider the gather all the age groups of all the audience, usually the age group is in between some for that movie, for that child movie, the age group is in between. Suppose, for example, some 5 to 15 years, the age group. If at all one person is there who is with the age 60, he is also attended to that movie because he is interested in child movies. He is interested in children movies. So he is treated as an outlier. Like that, why? Because he exhibits different behavior in terms of age compared to the remaining all children. So like that, we are having outliers. Sometimes outliers exist in our data. Sometimes maybe by mistake we have entered the outliers, or sometimes the data is inherently consisting of the outliers. So, and these outliers sometimes may be useful. Actually, these outliers shouldn't be useful for that for us, and we need to remove these outliers. Why? Because if at all you want to make some analysis, if at all you want to make some analysis because of the presence of these outliers, suppose you want to calculate the average age of the audience, average age you want to calculate. So if at all you only consider this, the average age is, I can say that the average age is uh, some 12 years. If at all you consider this range, because average can be obtained by obtained from sum plus count, sum of all the ages by number of participants, number of audience. So if at all I consider this age of this person also, the average age may become vary differently, right or not? మనం average ఎలా కనుక్కుంటాం? Sum of all the ages, because here the example is to consider the ages of the audience for a children movie Narnia. That means the director or the producer want to know which age group of people are interested to watch that film. That is the problem actually. So for that we need to add all the age groups of all the that means you need to add all the ages divided by the number of audience. So if at all you consider this 60 also there, what happened? ఆ ఏజ్ గ్రూప్స్ లో ఎడిషన్ ఆఫ్ ఏజెస్ లో 60 కూడా కన్సిడర్ చేస్తే ఏమవుతుంది? You may get the wrong average actually. Average age group మనకి ప్రాపర్ గా క్యాలిక్యులేట్ అవ్వదు. వై? బికాస్ 60 ఏజ్ గ్రూప్ ఉన్న పర్సన్ ఒకళ్ళే ఉన్నారు. But because of adding 60, because of including the particular age group also, you may get the average age group of approximately 30. You may get approximately 30 age group, but this is not true actually. So that because of that reason, we need to remove the outliers, and we need to treat the outliers as noise, and we need to remove the noise before proceeding for the clustering process. But in some cases, the detection of that outlier analysis is very helpful. Detection of that outliers is very helpful in such cases. In some cases, which cases? For example, fraud detection, medical analysis, customized marketing. So there are some applications where outlier analysis plays a major role. So coming to the fraud detection. In fraud detection, how outlier analysis can be helpful? Any guess? In case of fraud detection, how it can be helpful? Any guess? Just apply some common sense, you can get it, I think. Fraud detection lo ela help avutundi outlier analysis? You already know the basic idea of outlier, that is which exhibit some odd behavior. So in fraud detection, any kind of fraud, that may be the real thief, detecting real thief, or detecting the cyber thief, or what, or any kind of, how it can be helpful? Any guess? This is actually not relevant to the subject. In general, I'm asking. How outlier analysis? Outlier analysis is nothing but identifying the outliers, processing the data for identifying the outliers, like that. So how it can be helpful for fraud detection, or how it can be helpful for medical analysis. ఎవరైనా వింటున్నారా క్లాసెస్ లో?
Yes, ma'am.
జస్ట్ గెస్ట్ చేసి చెప్పండి. గెస్ట్ చేయడానికి కూడా బద్దకమేనా?
It identifies anomalies.
Identify
Anomalies.
anomalies in case of fraud detection,
Yes, ma'am.
or both in case of medical analysis also. So
Yes.
what it means, what is meant by anomaly here? In case of fraud detection, suppose మీ దగ్గర ఒక you have a group of people, suppose 50 people ఉన్నారు, వాళ్ళల్లో ఒకళ్ళు ఫ్రాడ్ చేశారు అనుకుందాం. సో పోలీసులు ఏం చేస్తారు జనరల్ గా? పోలీస్ పీపుల్ ఐడెంటిఫై ఈచ్ అండ్ ఎవ్రీ, అబ్జర్వ్ ఈచ్ అండ్ ఎవ్రీ పీపుల్, దట్ మీన్స్ పర్సనల్లీ ఎంక్వైర్, ఇంట్రోగేట్ ఈచ్ అండ్ ఎవ్రీ పర్సన్. సో హౌ దే డిటెక్ట్ ద ఫ్రాడ్ యాక్చువల్లీ? వాళ్ళు ఆ ఫ్రాడ్ ని, ఆ థీఫ్ ని ఎలా డిటెక్ట్ చేస్తారు? సో దే ఇంట్రోగేట్ ఈచ్ అండ్ ఎవ్రీ పర్సన్ పర్సనల్లీ. సో దే రికార్డ్ ఇఫ్ ఎట్ ఆల్ ఎనీ వన్ షోస్ ద అబ్నార్మాలిటీ. సో ఎవరైతే నిజంగా ఫ్రాడ్ చేశారో దే ఎగ్జిబిట్ సమ్ అబ్నార్మాలిటీ. So there they can identify the fraud.
Fluctuations in blood pressure, madam.
Yeah, fluctuations in blood pressure. So in case of medical analysis, if at all, so some X-ray report తీసుకున్నా, లేదంటే ఏదైనా blood pressure report తీసుకున్నా, if at all there is a fluctuation, high fluctuation, suppose the report is like that. So at one particular point of time, the fluctuation is like this. So it is identified as an anomaly. There is some mistake there. Some GCG, we can call it as some heart కి సంబంధించిన ఇవి చూస్తుంటాం మనం మూవీస్ లో. Some heartbeat fluctuations record చేస్తూ ఉంటుంది ఆ ఇన్స్ట్రుమెంట్. So if at all it getting some odd fluctuation, which means that is an anomaly, and we need to focus on that. We need to identify that what is that and why it is happened. Is there any problem with that patient, or generally it happens like that? So if at all there are abnormalities in the medical reports also, that can also be identified. So all these concepts comes under outlier analysis. So because there are some advantages also for going with the outliers, and there are some disadvantages also if you ignore the outliers and if you club the entire data. So for that you need to identify the outliers and you need to mine the outliers. If at all that outlier is useful, you can use it. If at all it is not useful for our data, you can eliminate that outlier. You can remove that outlier. That useless outliers are referred as noise. If at all they are useful, they can be referred as a useful outlier. So for that, first what is the outlier mining process? So given n data points, out of all n data points, k expected number of outliers are there, if suppose, then you need to find out the top k dissimilar objects. Suppose you have a data with you. You have some data consisting of n values. So out of n, you know that there are k outliers are there. So in such case, you need to identify top k number of dissimilar objects. That means some top k number of objects you need to identify which possess some different behavior. That means you need to identify the first object which exhibits some different behavior, and after that you need to identify the second object which exhibits the next different behavior next to that. Like that you need to identify top k dissimilar objects, and for that you need to first know what is the inconsistency. That means you want to identify the odd thing you want to identify. First you need to know what is the even thing. Even thing in the sense, what is not odd, you need to know that. 60 age group, age group of the person 60 and outlier and తెలియాలి అంటే, first you need to know that what is the general age group. So what is the consistency of the data then you can able to know what is the inconsistency in the data. That means you need to know about the distribution of the data well. So first you need to define the inconsistent data. ఎలా ఉంటే అది ఇన్కన్సిస్టెంట్ అవుతుంది. సో ఇందాక చూసాం హార్ట్ ఫ్లక్చువేషన్స్ సంథింగ్ ఇలా ఉండి ఇలా హై లెవెల్లో ఫ్లక్చువేట్ అయితే అక్కడ దేర్ యూ కెన్ ఫైండ్ సమ్ inconsistency. So before finding the outlier, first you need to define that what is inconsistent. Inconsistent in the sense this is the consistent range. If at all the fluctuation is greater than this range, I can define it as an inconsistent for this example. Like this, if you consider the age group of a person also, if the age group of a person is between 5 and if an age group of a person is in between 5 and 15, that is a consistent. Otherwise, it is inconsistent. So further, before going for the outliers, you need to define the inconsistent data. So sometimes for this, you need to identify the residuals in regression. So if you consider the regression analysis, so here we have already covered the regression analysis topic. So some data points may fall on the line and some data points may differ, right? So you need to find out the residuals in regression. So in order to go with the outliers, you need to calculate this distance. You need to go with this distance. If at all you have a point here, so this distance is very far from the regression line. So this can be treated as an outlier. Like that, you need to go for point to point in detail. But here we have faced some different difficulties in identifying that outlier, especially with when we go with the multidimensional data, and also when we deal with the categorical data. So whenever the data, when we go with the multidimensional data or when we go with the categorical data, it is very difficult to identify the such kind of deviations in the data exist. So we need to go for some other tough measures, tough techniques you need to go for identifying the outliers. So here visualization is one of the best methods for detecting the outlier. So here are some examples of the visualization techniques. So if you have a graph here, that means if you project the data here, so from this graph you can easily identify that these are the outliers. Similarly, from this graph you can use it based on this distance, you can easily identify that this is an outlier. So here also this is an outlier. So here also if you go with a box plot, so the objects which are fall outside the range of the box plot, min-max ranges are identified as the outliers. So like this, if you go for the visualization techniques, you can easily identify the outliers. But it is not with all the cases. It is not applicable to the cyclic plots, and also it is not applicable if the data is with the high dimensional data and categorical data. So for that, to identify the outliers for any kind of data, we have 4 approaches. So statistical approach, distance-based approach, density-based approach, and deviation-based approach. So go with each and every method in detail. Before that, just observe the titles, observe the names of the methods. Statistical approach. So it follows some statistics to detect the outliers. Distance-based approach. That means it follows some distance methods like this. It follows some distance methods to identify the outliers. And the third one is density-based outlier approach. That means instead of distance and instead of some statistical measures, it go with the density of the neighborhood to identify the outliers like this. Here, this is a density-based approach. Why? Because if you consider here, all these points are having high density, whereas these 2 points are having low density. That is only purely based on the neighborhood, the density of the neighborhood. So by going through the density-based approach, here these 2 points are referred as outliers. And deviation-based approach. Deviation-based approach. Here, this is deviated from the normal flow. Now, this is the path of the regular data. So here it deviates from this path. So in this case, it is an example of the deviation-based approach. Like that, you are having 4 approaches for identifying the outliers. Let's go with each of that statistical approach. So here it assumes that the data follows a probability distribution. So it assumes that initially each data should follow any kind of probability distribution, and each data have some distribution f. It assumes like that, and each data have with some mean and some variance, some standard deviation. So initially, before proceeding with this approach, you need to know about all these things. You need to know the distribution of the data. You need to know the parameters, other parameters of the data, like mean of the data, variance of the data, standard deviation of the data, like that. And here it uses some discordancy test to identify the outlier. So here in this method, it uses some discordancy test, which is any kind of statistical test which is represented with the T. This discordancy test is represented with the T. And it examines especially two kinds of hypotheses. A working hypothesis there, and another is an alternative hypothesis. So this discordancy test examines two hypotheses. One is working hypothesis and another one is alternative hypothesis. So where working hypothesis states that all the objects of the data set are belonging to the distribution F only. So what is the working hypothesis? It says that all the objects belongs to the distribution F. Whereas the alternative hypothesis states that the objects does not belong to the distribution F, they belong to some other distribution G. So they are not belonging to the given distribution F. They are belonging because they are something like outliers, and they are belonging to the distribution G. This is the alternative hypothesis. So this discordancy test verifies whether an object is significantly different from F or not. So what is the test? Actually, what is the task of the test means? It verifies whether the given object is differs from the given distribution or not. If at all it is different from the given distribution, it can be treated as an outlier. Otherwise, it is not an outlier like that. So if the value of the discordancy test is V, or specifically if the value of the discordancy test is Vi for a particular object Oi, if the test is made on this particular object Oi, the result is Vi, then we need to evaluate the significance probability of that Vi. Significance probability we need to estimate. If that probability is very small, then this particular object is treated as outlier. That means it is treated as a discordant. This particular object is treated as a discordant, and the hypothesis is rejected. What is the hypothesis? Hypothesis states that the working hypothesis states that there is no outlier in the data and all objects belonging to the same distribution. So if you go with this figure, all the objects belonging to this particular distribution only. This is the working hypothesis. There is no outliers in the data. All the objects follow the same distribution. Like that, the working hypothesis tells that this distribution is F. But what is an alternative hypothesis? There exists some outliers, and that belongs to some other distribution G. This is the alternative hypothesis. So here, if at all the significance probability is small, then that particular object Y is discordant. Discordant in the sense that is an outlier. And we are going to reject the working hypothesis. Rejecting in the sense we are going to adopt the alternative hypothesis. What is it? The alternative hypothesis that Y, that means the object, comes from another distribution model G is adopted here. So in this way, based on the value of the significance probability, we are going to reject or accept the working hypothesis. And here we are going to adopt the alternative hypothesis. So we have three alternative hypotheses, which is represented with G. Let us go through the each and every alternative distribution. The first one is inherent alternative distribution. The first one is inherent alternative distribution. It says that all objects arise from another distribution G. So it is represented with H prime, and it says that all objects are anomalies and all objects belonging to the other distribution G. And coming to the second one, mixture alternative distribution. As the name itself indicates, mixture. Mixture in the sense it consisting of the combination of both distributions F and G. So it says that discordant values are not outliers but contaminants from another distribution G. That means it says that some of the objects belonging to the distribution F and some of the objects belonging to the distribution G, but not all the objects belonging to the distribution G. So here it is expressed like this. So 1 minus lambda fraction of the objects belonging to the original distribution G, whereas lambda fraction of the objects belonging to the distribution alternative, that means another distribution G. That is the mixture alternative distribution. And the last one is slippage alternative distribution. So it says that some of the objects belonging to the original distribution F, where some other objects which are referred as discordants are belonging to the other distribution, some F prime, which is a different version of the initial distribution F. So here some objects are independent observations are from a modified version of the F with different parameters. That means this is also the same distribution, little a modified version of F. Maybe the parameters may change, mean value may change, or standard deviation may change like that. But this is not a different distribution. So this is all about alternative distribution. And finally, here for identifying the outliers, we are having two procedures under statistical based distribution based outlier detection. So one is block procedure and second one is consecutive procedure. So what is the block procedure? So it says that all the suspected objects are outliers. There is no partial outlier or partial normal object. So block procedure says that all the suspected objects are outliers. Whereas consecutive procedure, it says it implements some inside-out procedure for detecting the outlier. What that procedure means? It initially identifies the least likely object. That means least suspected object. Suppose we are having a set of suspected objects. So this is the neighborhood. Just this is the imagination. These are all the points we are having, and this is here is another boundary, and here is another boundary you have drawn. This is all your imagination only. And here is an object in this boundary, and here is another object in this boundary, and here is another object above the boundary. So generally, what is my first suspect? Based on the distribution of the data, what is my first suspect? This is my first suspect. This is my second suspect. This is my third suspect. Why? Because this is little far to the remaining elements. Whereas this is next suspected object. This is little more far to the remaining elements. And this is the next suspected object. So here in this method, now first we need to identify the least suspected object, least likely object. Or suppose here you have another object, some X. So you have doubt that X is also an outlier. So like that, first you need to identify the least significant object. Me first ఏదైతే డౌట్ ఉందో అవుట్లయర్ అని దాన్ని ఐడెంటిఫై చేసి you need to first go with the entire procedure whether this X is an outlier or not. So if at all this X is an outlier, then ఈ బౌండరీకి అబౌవ్ ఉన్న నెక్స్ట్ సస్పెక్టెడ్ ఆబ్జెక్ట్స్ ఏవైతే ఉన్నాయో ఇవన్నీ కూడా అవుట్లయర్స్ అని మనం డిక్లేర్ చేయొచ్చు. సో ఇఫ్ ఎట్ ఆల్ ఎక్స్ ఈస్ నాట్ అన్ అవుట్లయర్, ఇది అవుట్లయర్ కాదు అని వచ్చింది అంటే నెక్స్ట్ యూ నీడ్ టు గో విత్ ద నెక్స్ట్ సస్పెక్టెడ్ ఆబ్జెక్ట్. What is the next suspected object? Next possibility ఏది? P may be the outlier. So again you need to go with the entire procedure and you need to check whether the P is an outlier or not. So if at all P is outlier, you can confirm that Q and Z are also outliers. If at all P is not outlier, that means what? ఈ బౌండరీలో ఉన్నది కూడా outliers కాదు. Then you can go with the next possible suspect and check whether that is outlier or not. Why? Because if at all X is an outlier, no need to check for all the remaining P, Q, Z, right? If at all X is not an outlier, trial and error method. If at all X is not an outlier, then only you can go for P, like this. So this is about the statistical distribution based outlier detection, but here we have some disadvantages also with this method. What is that mean? This method works only for the one-dimensional data, single attribute but in real time we don't have we may have multiple dimensions of the data, and here it assumes that data distribution for this data distribution should be known in advance. Data distribution should be known in advance, but this is also not the case all the way. Sometimes we may don't know about the distribution of the data in advance. So in such cases, it is not helpful. That's why we are going for the next method, that is distance-based outlier detection. So as the name itself indicates that it detects the outliers based on certain distance methods. So here, dB of P comma D outlier is an object. It defines that an object go in the dataset T such that, so here this outlier is an object go in the dataset T such that at least a fraction P of the objects in T lies at a distance greater than D from O. Let's consider an object O as the set. This is the object O. So here this is the dataset T. Just imagine a boundary. This is not a cluster. This is some neighborhood boundary. Just like magnetic field, as I told in the last class, right? This is a dataset T, and we are having certain elements here and there. If you observe, some of the elements fall within the neighborhood of O, and some elements may fall outside the neighborhood, but all the elements belonging to the dataset T. So if O is an outlier, O outlier eppudu avutundi ante, at least a fraction of P of the objects in T lies at a distance greater than D from O. Suppose this is that distance. This is the distance from O. So, ఒక object ని consider చేసి అక్కడి నుంచి some, let us say, D distance యూజ్ చేసుకొని ఆ బౌండరీని మనం చెక్ చేయాలి. So we need to first calculate the fraction of P points out of T. Let us say this is X. Some percentage of that, may be the 10% or 5% or 20%, that is not the matter. Some fraction of the entire data set. Let us say this is X. Suppose X number of items kanuka neighborhood of object O లో ఉంటే, then that is not an outlier. Otherwise it is an outlier. That means మనం ఇక్కడ ఏం చేస్తున్నాం, we are checking whether the object O has enough number of neighbors or not. Enough number అనేది that is represented with this fraction X. That is represented with X. Here if suppose X is equal to some 3, for example. X మనకి 3 వచ్చింది అనుకుందాం. So how many neighbors are there within its neighborhood? This is actually D neighborhood. Epsilon radius తో neighborhood form చేస్తే that is epsilon neighborhood. ఇక్కడ D radius తో neighborhood form చేస్తే that is D neighborhood. So within the D neighborhood of the object O, how many neighbors are there? Actually 3 neighbors are there. ఇక్కడ you can identify 3 points, right? Here is a point, here is a point, here is a point. Since it consisting of that, it satisfies this value, that is not an outlier. If at all this value is 6, but we don't have 6 elements within that neighborhood, then O is a outlier. That is what here. So this is represented as dB of database of, that means distance based. dB in the sense distance based. P comma D. P is a fraction. P is a fraction, and D is a distance. So here outlier, this distance based outlier is an object O in database T such that at least a fraction P of the objects in T lies at a distance greater than D from O. So if at least 6 objects lies at a distance greater than D, that means out of boundary లో at least 6 objects ఉంటే, అంటే దాన్ని ఇన్వర్స్ అనలైజ్ చేస్తాం. అంటే less than 6 values కనుక, within the boundary exist aithe, then that is an outlier. Otherwise it is not an outlier. That means indirectly we are checking whether the object have enough neighbors or not. So it avoids the, so in this method it avoids the excessive computation of statistical methods. So if an object is an outlier according to the discordancy test, that means in the previous method you have identified the object whether it is an outlier or not based on the discordancy test, right? So if at all an object O is here, if at all object O is outlier, it is already identified as an outlier according to the previous method. Then in this method also it is an outlier for some P and for some D. So for a given D and given P, the object is also identified an outlier if it is an outlier, if it is identified as an outlier in the previous method. So statistical based method lo ad outlier ga declare aithe danni ikkada manam distance based method lo kuda outlier ani cheppochu with some given P and D. So ikkada D ni D min ani kuda antam. D is also referred as D min neighborhood. So here several algorithms are there for mining distance based outliers. Several algorithms are there. Let us consider the first one, index based algorithm. So as the name itself indicates, it uses multidimensional indexing structures like KD trees, R trees to search for neighbors. So here maximum number of objects within D min neighborhood it needs to observe. Suppose an object O is there and within this D neighborhood, D or D min both are same, right? So within this neighborhood, previously I told you, right, a fraction P of the entire data set is considered actually. So particularly in the index based algorithm, m number of that fraction is considered as m. That means instead of fraction, it directly considers the value m. That means at least m number of items should be there within the neighborhood. If that is the case, then O is not a outlier. Otherwise, O is a outlier. For example, let us say m is equal to 3. So here, for example, you are having 3 plus 1 neighbor. For example, you are having 3 plus 1 neighbor. Then O is not a outlier. So that count should be greater than or equal to m. So look at here. So maximum number of objects within the D min neighborhood. This is the D min neighborhood. So only m objects are there or maximum m objects are there, then that is an outlier. Once m plus 1 neighborhood is found, that means more than m objects are there within this neighborhood, then this is not an outlier. So maximum boundary is m. If more than that exists, that is not an outlier. So this worst case complexity is big of n square k apart from the index construction. And next coming to the nested loop algorithm. So here it avoids the index construction and it tries to minimize the number of input-output operations. So it actually divides the total memory into 2 blocks. It divides the total memory into 2 blocks, and similarly it divides the data. This is our data set T actually, right? It divides the data set into several logical blocks. So it divides the total memory into 2 halves and it divides the data space into several logical. So by carefully choosing the order in which the blocks are located into the each half, why? Because you need to, if you want to do some process, you need to load the data to the memory. So which block of data, which logical block of data is loaded into the which part memory? That is important here. So by carefully choosing the order in which blocks are loaded into the each half, IO efficiency can be achieved in case of nested loop algorithm. So let us go for the next algorithm, cell-based algorithm. So here, as the name itself indicates that here entire data is partitioned into the different cells. So here its complexity is big of C power k plus n. where C depends on the number of cells and K depends on K is the dimensionality. So here the data space is divided into several cells. The data space is divided into several cells, where the side length of each cell is d min by, what is d min? 2 power k. What is d min? ఈ distance మనం d min అంటాం. So side length of each cell is d min by 2 root k. This is the side length. And next, each cell is surrounded with the 2 layers. Let me change the color. My time is over. Don't observe. We'll continue this in the next class. 11 ke kada class అయిపోయేది.